Hello everyone. During JOSAA counseling, the top choice for most students are the circuital departments, meaning computer science, electronics and electrical. Immediately after this, among the non-circuital branches, it can be arguably said that the top choice for students is generally mechanical engineering. However, when filling these choices, students often take an uninformed decision, meaning they choose mechanical without really understanding the various aspects of mechanical engineering department. So in this video, I thought it will be a good idea if I can give a broad overview of the department, mechanical engineering department. I shall divide this video broadly into three parts. In the first part, I'm going to discuss the various types of courses which are taught in mechanical engineering. This is very important. Second, I shall be discussing two surprising aspects of mechanical engineering which I'm sure most students are not aware of. And third, I'm going to discuss, based on these first two things, the suitability of mechanical engineering for different kinds of students. So at the very first, the different kinds of courses which students have to study. Now broadly, mechanical engineering is divided into three divisions. First, you have the applied mechanics or design and dynamics. Now in certain institutes like IIT Delhi and IIT Madras, you have actually a separate applied mechanics division, but broadly in most institutes you have the design and dynamics division within mechanical engineering, which is also sometimes referred to as the applied mechanics division. In this division, the kinds of courses which you have to undergo are solid mechanics, dynamics, machine design, vibration analysis, control, and in certain places robotics, although at IIT Kharagpur robotics comes under another division. Now as a +2 student, as a student who has just passed +2, you may not be quite aware of these things. So very quickly I'll go through them. Well, solid mechanics, you have to deal with mechanics of solid bodies, of course, but meaning deformable solids. Okay, so the deformation is important. In dynamics, you usually deal with rigid bodies. So this is the subject which is the closest with what you study in the mechanics part of physics at +2. The problems are very similar, although much more advanced level. Like if you thought that mechanics at the JEE level is difficult, you should see the problems in dynamics. But it's very exciting also, and many students find it fascinating, absolutely, although very challenging. And it goes beyond particle level dynamics. Next, you have things like vibration analysis, which comes in the later years. This goes beyond things like simple harmonic motion, wave motion, that sort of thing. And in control, you have of course the how do you go about controlling various aspects of mechanics. Now control is something which has a very close resemblance with what people study in electrical engineering also. Next division is the thermal and fluid sciences or thermal and fluids engineering. Here of course you study fluid mechanics, heat transfer, thermodynamics, the three pillars of this division. And then you also have a lot of applied things like applied thermodynamics, turbo machinery, internal combustion engines. So in fluid mechanics, it is like a close counterpart of solid mechanics. You apply mechanics to fluid flow, where you have a little bit of a introduction to it in your +2 physics, but very little things where you talk about Poisson flow, Reynolds number, these sort of things, but it goes much beyond that, talking about things like Navier-Stokes equations, the famous Navier-Stokes equations, and various sorts of aspects associated with fluid mechanics, fluid flow. Next, in heat transfer, you talk about things, of course, conduction, convection, and radiation, but it goes much beyond the kind of things which you have learned in high school. And in thermodynamics, of course, it builds on what you studied in your +2, but there are a lot of new things which you have to study also. And very importantly, within mechanical engineering, thermodynamics, as you study it in the undergraduate, it is applied to a lot of application areas. That is what you study. Now the third division is manufacturing. In certain places it is referred to as production. Now manufacturing, as the name suggests, are the kind of courses where you study how to make things. Basically it's that. But within that there are certain classical courses like casting, forming, welding, as well as machine tools and machining. These are some of the very traditional kinds of fabrication or manufacturing processes. In addition to that, you also get to study some kind of non-traditional manufacturing things involving applications of electromagnetism as well as laser. Now, these are not newfangled things. These are very classical things within manufacturing science and engineering, although they are referred to as non-traditional things. You also get to study things like, as a very small example, because you do not have much idea about manufacturing, you also get to study some very exciting things like cutting metal with a jet of water. So believe it or not, that is possible. All right, so these are the various kinds of courses, a very like a blazingly fast overview of the various kinds of courses. You can take a look at the detailed syllabus, the curriculum in any good institute website. Now, the next thing that I want to discuss, this is the second part of this video. I want to discuss a couple of surprising aspects of mechanical engineering which most students are not aware of. Now, if you have just listened to what I said about the different courses, it is natural for you to think that yes, most of these courses seem to be like application areas of what you are studying in physics in +2, and that is true. But what people do not realize is that a lot of the topics within these courses from all the three divisions, but mostly from the design and dynamics as well as from the thermal and fluid part, they can be considered to be applied mathematics. Okay, they can be considered to be applications of applied mathematics. This is something which people absolutely do not realize. I want to emphasize this because many of the good students who come through the JEE process into these engineering institutes, they are somewhat strong in mathematics. Many of them are very strong in mathematics, and because they are strong in mathematics, they have also been through they have also participated in Olympiads, and it just so happens that the Olympiad syllabus is more concentrated towards the pre-calculus things, meaning things involving algebra, geometry, permutations and combinations, and of course number theory. So there is not much calculus in that, and these students, they think that they are good in mathematics and they are maybe good in Olympiad level problems. So because they are good in mathematics, they should not be taking mechanical engineering. Maybe they should go into they are only mostly suitable for mathematics and computing and computer science. That is true. If you're really good at Olympiad level problems in mathematics, you are definitely suitable for those departments, mathematics and computer science. But what people do not realize, and this is what I want to emphasize here, is that in mathematics, within the pure math side, you have these things. But there is an entirely separate thing called applied mathematics, where things are built up on the foundations of calculus, and not just the kind of calculus which you have been exposed to in your +2, rather the kind of multivariate calculus which is extremely exciting and fascinating. And these are the kinds of things in applied mathematics which finds a lot of applications in physical problems, and a lot of these problems are there in the areas of solid mechanics and fluid mechanics. Please note that when I mention these things, I am not just referring to things which are taught at the higher levels. Okay, you do not have to even go for higher studies to realize that you are actually studying things which are basically applications of applied mathematics. In your very undergraduate level courses also, you will realize this. In fact, it is true to such an extent that I would say that people who are not very keen on doing mathematics should think twice about taking mechanical engineering. There is so much of applied maths in mechanical engineering. The next thing which I want to highlight is many students at their school level, they get interested in computer programming. This is quite common nowadays, and based on this interest, they think that they are suitable mostly for computer science and engineering. But the funny thing is, in hardcore computer science, the intellectual core of computer science does not have too much to do with programming. Now, when I say this, I am making a distinction between the hardcore part of computer science separately from the software engineering part. where of course there is a huge lot of programming. There is no denying that. But the hardcore aspect of computer science and engineering is not intrinsically dependent on programming. There are other much more intellectually deeper things there. Now suppose a student is there who is really interested in the programming aspects, okay, and at the same time he is interested in things, in scientific things. So I would say the most natural choice for him would be physics. This is the most natural choice. Of course, many students are not keen on taking up basic sciences after finishing JEE successfully. So the next best option I would say is mechanical engineering. And when I say mechanical engineering, I broadly mean the departments based on the mechanical sciences, like mechanical engineering, aerospace, and also separately chemical engineering, because there's a lot of computer programming involved there. If you're the kind of student who has a good knack of visualizing complex geometry in your head, and you are also interested in how those things can be applied to various kinds of physical problems using programming, then there is a very fertile area for you to work in mechanical engineering. This is the place to be. Now, when I say these things, it certainly does not mean that from the very first day that you start studying mechanical engineering, you're going to be able to do these things. You'll be able to do these things only at the higher levels, maybe when you do some kind of projects, and certainly when you go into higher studies. All right. The next aspect that I want to discuss based on all these discussions that I've had till now is the suitability of mechanical engineering for the various students. I'd already mentioned a very important point, that because there is so much of applied maths in mechanical engineering, if you're the kind of student who is actually very good in maths, then you should really think about taking up mechanical engineering. Like if you're really good in maths, you have a certain knack for it, there is a big chance that you'll be able to do very well, especially if you go into higher studies and into the academic line. On the contrary, if you are the kind of student who is not very keen on maths, okay, somehow you want to avoid it, then maybe just because your rank is allowing you to take mechanical engineering, don't just jump into it. Think twice, think thrice before taking up mechanical engineering. There may be a few other departments where you may be able to thrive better than mechanical engineering, even though your rank is allowing it. Okay, so I try to emphasize this point again and again. Just because your rank is suitable for a certain department, is allowing you to take a certain department, whether it's even a circuital department, don't just jump into it. Try to realize what kind of thing your brain is attuned to. Okay, we had a very famous professor in mechanical engineering department. He's gone now, he's passed away a few years ago. He used to say, not everything is for everybody. Okay, this is a very important line and thing to understand. Okay, not everything is for everybody. You have to find, so a big recipe for success in life is to find the thing which you are most suitable of doing. I think Albert Einstein also, a famous quote is attributed to him, is that if you ask a fish to climb a tree, of course it is going to fail. Okay, so find your water, find your domain. Finally, I've said a lot of things, very good things about mechanical engineering, very challenging things which are there in mechanical engineering, but at the end I would say that some of the most exciting things in mechanical engineering, in order to be able to reach that level, you have to go into the higher levels of mechanical engineering, you have to go into the higher studies. If your intention, however, is to somehow get a job, okay, just at the end of 4 years of study, then this is probably not the way to go. Okay, then so this is probably the situation with the most average students. They somehow want to get a job, then maybe think twice, think thrice before choosing your department. Okay, go into a department where there is the most chance of getting a job, even if you happen to have a mediocre result. Go for it. But I want to emphasize again, if you're really interested in the kind of things which you have discussed in this video, go for mechanical engineering. you will actually be intrinsically happy. And I think if somebody is really interested and happy on a day-to-day basis, learning something and actively pursuing something, then there is a greater chance for him to succeed in that line of career. So with this word of advice, I'll end this video. Thank you very much and all the best.